So in the previous video we have learnt about the different laws of reflection and the terminology regarding the on curved surfaces and like pole, principal axis and center of curvature, radius of curvature, focal length and all these things we have been discussed and just introduction of them we have done in the previous video, and now we are going to discuss in detail about these terminology. Okay, what are the terms which we are going to use in this chapter? These are very important terms for the examination purpose also. There may be a chance of asking any four terms for 4 marks also. Define the following terms like that. So radius of curvature, the first one is, let us take radius of curvature. Radius of curvature, first one. And radius of curvature, how can we say the radius of curvature? That is the distance between, if we take any curved surface, this curved surface consisting of these terms this is one point, this is P. The P is representation for pole, and here one more term will be there, that is one more point will be there, that is F. F is representation for principal focus. F is representation for principal focus, and another point will be there, that is C. C represents the center of curvature. C represents the center of curvature. Okay, in this center of curvature is represented by C, and principal focus or focal point also we can say. Principal focus or focal point also we can say, and this principal focus or focal point is represented by capital F, and this P is nothing but pole, and it is center of this curved surface. It may be center of this curved surface, and C is the center of this curved surface. The center of curvature, this radius of curvature is represented by capital R, and the distance between pole to the center of curvature. The distance between pole to the center of curvature is called radius of curvature. It is represented by PC is equal to R. PC is equal to R. The distance between pole and center of curvature is known as radius of curvature. It is represented by capital R. And in the same manner, principal focal length will be there, and here you may see pole, P for pole, F for principal focus or focal point, C is center of curvature. All these are points, and here we are discussing about the distances, and in these distances we have discussed about radius of curvature R, that is PC is equal to R. And in the same manner we have to discuss about the focal length also. Focal length, here focal length is represented by small f, whereas principal focus is represented by capital F. The symbols are very important. Capital F is represented representation for focus, that is principal focus, and whereas small f is representation for focal length, and focal length can be defined as the distance between pole and principal focus. The distance between pole and principal focus is defined as focal length. Focal length. It is represented by small f. It is represented by small f. The distance between pole and principal focus. The distance between pole and principal focus is called focal length. It is represented by small f. whereas radius of curvature is represented by capital R, that is the distance between pole and center of curvature. Pole and center of curvature is known as radius of curvature. So the definition we can write for the radius of curvature also, that is the distance between B for W stands for between, the distance between pole and center of curvature. The distance between pole and center of curvature is called radius of curvature. Is called radius of curvature. It is represented by capital R. It is represented by capital R. And here next topic we are going to discuss the relation between this radius of curvature and this focal length. What is the relation between the radius of curvature and the focal length we are going to discuss. And here there is a relation. It is a very important relation in the in this chapter, that is the relation between radius of curvature and as well as focal length. So here in all the cases we may have seen this is pole, this is the point pole, and this is called principal focus, and this is called center of curvature. It was observed that always this PF is always equal to FC. PF is always equal to FC. That is, when we take this as a, if we take this as a line segment, the PC bar can be represented by PF plus FC. PF plus FC. So PF we know, that is PF is equal to F, but from this equation we know FC is equal to PF. That is FC is equal to PF bar. Then PC bar we know what is the distance between P and C. This is equal to R. So R is equal to F plus F. That is R is equal to 2F or F is equal to R by 2. This is a very important relation which will be useful in problem solving. And first chapter is very important for problems which are asked based on the image formation and distance between image and object. So in that it will be given indirectly when radius of curvature will be given, and if radius of curvature is given as 20 centimeters, then he will be asked to find the focal length. He will be asked to find the focal length. According to this, focal length is equal to R by 2, then it is 20 by 2 is equal to 10 centimeters. So focal length directly we can find by using this formula with this relation, F is equal to 10 centimeters. Okay, remaining terminology we will discuss in the next video, and please subscribe my channel and share and comment so that we can improve our channel.